You learned last time to do integration by parts. All right, so hopefully you've done that homework. If you're having trouble, email me and we'll figure out, try to find your mistakes and figure out what you need to do to fix it. Hopefully it's going great. It's not that hard. Okay, we're going to do integration by parts again in this video, but we're going to kind of show you two things. One is sometimes you can use a shortcut called tabular method, okay, and sometimes you can't, all right? So the way that you know you can do the shortcut with tabular method is this. There are basically two conditions to using tabular. You know, you've got your integrand, and part of it's your u and part's your dv. Well, for you to use the shortcut, the part that you pick for u, if you keep taking the derivative repeatedly, that derivative has to eventually turn into a zero. So that's condition number one. And then condition number two is the other part that you let be dv, of course, you have to be able to integrate. So some of the ones that you worked last time for homework, you could go back and rework tabularly, and some of you might not be able to, okay? So I'm going to pull up a PowerPoint and kind of explain the steps, and then we'll do a couple of examples to kind of show you that. Okay. So on tabular, okay, you do it the same way, but you make a table. That's why it's called tabular. Okay, here are your steps to making the table, all right? The table's going to have three columns, all right? The first column is going to say sign, S-I-G-N, and the second column is going to be what you pick for your U, and the third column is going to be what you pick for your DV. So your sign, your U, and your DV. Now remember, you take the derivative of your U, so that middle column that's U, you're going to take derivative of that second column. Your third column that's DV, you're going to integrate that column. Okay, your sign, your first column always starts with a plus, and then you're going to alternate like plus, minus until you stop the table. Now, how do you know when to stop the table? You stop the table when the middle column is zero. So when that derivative eventually turns into zero, that's how you know that's your last row. Complete that row, and then you're finished with the table. How do you get your answer once you have your table? Well, the key is here, you'll see what I mean in a minute, but you're going to go across and down, not just across and across, okay? And you're going to multiply along the arrows. That'll get you your individual terms in your answer, and then you connect those individual terms with a plus, okay? So let's go look at an example to show you what I mean. We're going to integrate x squared cosine x. Now, how do I know I can do tabular? Because one of these, either the x squared or the cosine x, one of those two pieces has to have its derivative eventually go to zero. So if you take the derivative of x squared repeatedly, you know, the derivative of x squared is 2x, the derivative of 2x is 2, the derivative of 2 is 0. So I've got a piece whose derivative would eventually go to 0 if you kept taking the derivative. So that's condition one. And then condition two, the part that's left over that you let be dv, you have to be able to integrate. Okay, just like before. So you've got a sign, a U, and a DV. All right, now remember what I told you about the sign column. You always start with plus, and then you alternate. Plus on the first row, minus on the second row. Plus, minus, until you finish making your table. All right, so you let U be your x squared, and you're going to take the derivative of all these, and DV is the part that's left. Now, DV is really cosine x dx, but when you're doing tabular, we don't write down the dx part, okay? Now, I go to the second row because this was plus, that's minus. Now, how did I get my 2x? Remember, this is your u, so after that, you're taking the derivative, and the derivative of x squared is 2x. What happens next? Well, this is your dv, so now you have to integrate to get the row below it. So when you integrate cosine x, you get sine x. So that's where I got the minus, the 2x, and the sine x for my second row. How did I know I wasn't finished? Because I don't have a 0 yet in the middle column. So I've got to do another row. So it alternates. So if that's minus, that's plus. The derivative of 2x is 2. If you integrate sine x, you get negative cosine x. Okay? I keep going because I don't have the middle column 0 yet. So if this one's plus, that one's minus. The derivative of this constant, of course, is 0. So that's how I know this is my last row, but I've still got to finish the row. When you integrate cosine x, you get negative sine x. Now think about why. You pull your negative out of your integration, and when you integrate cosine x, you get sine x. So that's why you get negative sine x. So there's your alternating signs, plus, minus. There's your u with its derivative, and there's your dv with its integrations. Now remember what I said in the steps, you go across and then you go down, not across and across. So you go across and down to draw the arrows, and across and down. And you're going to multiply along those arrows. So I'm going to multiply a plus times an x squared times a sine x. Plus times x squared times sine x. Then I go to the next set of arrows. A negative times a 2x times a negative cosine x. A negative times a 2x times a negative cosine x. And then the last one, a plus times a 2 times a negative sine x. A plus times a 2 times a negative sine x. So those black things are what I got when I multiplied across and down. And then remember what I said on the steps. Those terms always get connected with pluses. There's always going to be pluses between the terms. And then you just simplify it. This multiplies up to give you x squared sine x. Well, a negative times a negative is a positive, so that's why I've got a plus there. And then I've got plus a negative is a minus. And then don't forget your plus c at the end if it's an indefinite interval. So that's how I got that answer. All right, let's look at a couple of other things. All right, here's another one to kind of give you an example in a definite interval. All right, I'm going to integrate x e to the negative 3x, but it's a definite interval, so I'm going to go from 0 to 2. So I'm going to use tabular to kind of get the indefinite answer and then substitute my numbers in. So remember, plus minus, it alternates, always starting with plus. X is the piece whose derivative eventually goes to 0, so that's why I pick u to be x, and then the rest of it, e to the negative 3x is my dv. So if this is plus, the next row is minus, the derivative of x is 1. If you integrate e to the negative 3x, you get this answer. Look at why. If you integrate e to the negative 3x, remember you need the derivative of your power. If I multiply by negative 3, I've got to multiply it here by negative 1/3. So that's why I get that negative 1/3, and then when you integrate e to the negative 3x with that derivative, you get e to the negative 3x back. So that's where I got that answer. The middle column, isn't 0 yet, so I've got to do another one. So if that's minus, that's plus. The derivative of constant 1 is 0, and if you integrate this thing, you get that thing. Okay, you can freeze it if you need to double check my work. But I moved the negative 1/3 out. Then I still needed another negative 3 for this one, so I need a negative 1/3 out here. Then, of course, this negative times this negative is a positive. Now, remember what I said. I know that's my last row when that middle column is a 0. But then I go across and down and across and down. And I multiply. So a plus times an x times this term is what I have right here. And then I've got a negative times a 1 times that 1/9 e to the negative 3x here. And then remember, you always connect your terms with a plus. All right. So I simplified that and got a negative 1/3 x e to the negative 3x. And then plus this negative makes it a minus. Now remember what I'm doing though. If it were an indefinite, I'd put plus c and be finished. But it's not. It's definite going from 0 to 2. So remember that 2 gets plugged in for the x first. And then that 0 gets plugged in for the x second. And then remember, you subtract f of b minus f of a. So when I simplified that, I got a negative 2/3. And then I've got e to the negative 6 minus that 1/9 e to the negative 6. Now look over here. 0 times anything is 0. Then remember, e to the 0 is 1. And 1 times 1/9 is 1/9. So that's why I got that for my final answer. Okay, so tabular is pretty simple. All right, always start with the plus. Your u is in the middle column with its derivatives. Your dv is in the third column with its integrations. Now, let me show you one that you cannot do tabular. Okay, and it's integration by parts more than once, but it's kind of a trick to it that you might not think. This special case only happens when you have an e to the x with sine x or an e to the x with cosine x. All right, and here's the reason why. The derivative of e to the x is going to keep being e to the x. And the derivative of sine and cosine flip back and forth. So if you took the derivative of sine twice, you'd be back at a cosine. Took the derivative of cosine twice, you'd be back with the derivative, you'd be back with the sine. So look what happens. I let u be e to the x and dv be my sine x dx. So if you take the derivative of e to the x, of course you get e to the x. If you integrate sine, you get negative cosine. So I did my uv minus the integration of v du and plugged in. You know, there's my u, there's my v, there's my v again, and there's my du. So I just substituted in from over here. You can stop the video and double check it if you need to. So I did this one times this one and simplified it. Now remember, I pulled that negative out, so I've got minus the negative, and then I just switched the order here, just so, because I kind of had this one with the e first, and you're going to be able to see something more easily if I do it this way. Now minus the negative is a plus, but see, I'm kind of stuck. I can't integrate that one. Okay, so I've got to do integration by parts again. Now here's one main thing. If you let u be e up here, u needs to be your e down there. Okay, so I let u be e to the x, and my dv is my cosine x. So the differential of u, the derivative of e to the x, is e to the x. Now I need a dx right there, but I ran out of room. Okay, and then if you integrate cosine, of course, you get sine. So this purple kind of goes with this integration by parts. So I did my u times my v minus the integration of my v times my du on this integration by parts. And then I simplified it. All right, so that just comes down, plus, there's that. Now, plus a negative is going to be minus. Now, here's kind of the trick when you have e with sine or e with cosine. When you do integration by parts twice, I want you to notice this integration and your original integration. Do you see they're identical? Okay, so this one matches this one. So what I'm going to do is I'm going to move that one over. In other words, I'm going to add this to both sides. So when I move this over, or I add them, because they're identical, instead of having one of them, now I've got two of those same integrations. And then, of course, that's left over here. Well, I don't want the answer to double the integration. I want the answer to just one integration. So to solve for just one integration, I just divide both sides by 2. And so when I do that, I just get this thing divided by 2. And don't forget your plus c, because it's indefinite. So that's a little trick when you have e with sine or e with cosine. If you do it correctly, when you do integration by parts twice, your original integram will show up over here, and then you move it over. Now, if you have e to a 2x or the sine of 4x or something, you might not always get 2 of them. It might be that this integration is 5 of them, and when you move it over, now you've got 6. So you're going to have to divide by whatever's in front of this integration. So I'll probably give you one to do for homework and let you try. But again, if you're having any trouble, I need you to make sure that you're emailing me or coming to those Zoom meetings, okay? Because, you know, those Zoom meetings are optional, but that is a time for me to work some homework problems for you if you need me to, okay? Ask me questions, but you can also snap pictures of your homework and send me those, and I can try to find your mistake and send you some feedback back. So if you need me, you know how to contact me. All right, so now I'm going to watch the video, go try the homework, and let me know if you need any help.